So continuing where we left off, we've selected a pair from the deck. There's 78 ways we can do that. Now we're trying to count the number of ways we could pick 3 additional cards from the deck that do not match one another in rank and also do not match the rank of the pair that we drew. We've talked about 2 possible solutions, neither of which is correct, both of which because they don't take into account avoiding duplicates of the ranks of other cards in the hand. The third method would use the multiplication principle, or the MN rule. Once you've drawn your first 2 cards, and they're the same rank, maybe they're both jacks, there are a total of 48 remaining cards that you could draw from that wouldn't be jacks in the deck. And so you have 48 ways to draw the next card, the third card for your hand. And now, once you've drawn that card, you have another rank that you need to avoid. So maybe you have 2 jacks and then a 5. So there remain only 44 cards after that that don't match the pair you started with and the rank of the third card that you would draw. And so for your last card, there are 40 cards in the deck that are not jacks or whatever your pair was, and are also not one of the 2 ranks of the cards that came before. This also is not quite right, and the problem with this count is that it would count the same 3 cards in the 3 additional cards drawn more than once. It would count the 5 of clubs, the 7 of diamonds, and the 4 of spades once, as 48 times 44 times 40, but it would also have counted that as a separate possible choice, the 7 of diamonds, the 5 of clubs, and the 4 of spades done in that order. So this overcounts the number of possible ways to fill out our hand. But it overcounts in a very specific way. It overcounts by a factor of 3 factorial, because there are a total of 3 factorial ways we could permute these 3 cards chosen in some order. So method 4 is to take this previous answer and fix it by dividing by 3 factorial. And this actually is it gives us a correct answer. 48 times 44 times 40 over 3 factorial. This is a correct answer for the number of ways of drawing the remaining 3 cards. Now 3 factorial is 6. 6 goes into 48 8 times, and so those will drop out, and we'll end up with 8 multiplied by 44 multiplied by 40, which works out to being 14,080. That would be the number of ways of drawing our 3 additional cards. If we then wanted to finish the problem and count the number of ways of getting a pair when you draw 5 cards out of the deck, we would need to multiply this answer by 78. But before we go ahead and do that, I want to look at a 5th method of counting the number of ways of drawing these 3 additional cards. So the 5th method would involve doing 2 separate things. The first would be to pick the ranks that the 3 additional cards are going to have. Now they can't match one another, but they also can't match the pair that we already started with. So there are 12 ranks remaining that we could choose from, and we want to choose 3 distinct ranks from the 12 that are available. And so 12 choose 3, which gives us 12 times 11 times 10 over 3 times 2 times 1, which, 6 goes into 12, leaves behind a 2. This is 220. Possible ways of choosing the ranks for the 3 remaining cards. And then for each of these 3 cards, we're going to pick a suit for each card to have. And here, it doesn't matter whether the suits duplicate or not. And so since there are 4 choices for the suit of the first card, and 4 choices for the suit of the second, and 4 choices for the suit of the third, we end up with 4 cubed. And so this leads us to the answer 4 cubed multiplied by 220, which happily agrees with the answer we found in method 4, 14,080, the total number of ways of filling out our 3 additional cards. So for problem 11, the question of how many 5-card poker hands there are in which we have a pair will be 78 multiplied by 14,080, which works out to being 1,098,240. The probability that we would end up getting a pair would be that 1,098,240 divided by the total number of possible 5-card poker hands, which was 2,598,960, which works out to being right around 42%. So the probability of getting a pair when you're dealt a 5-card poker hand is 0.42 or 42%. I hope you found this useful. Thank you very much.